So for example, we're going to draw the influence lines for vertical reactions at supports A and C. So we need to get the influence line for reaction at A and then reaction at C, and also the shear and bending moment at point B. So we're going to cut through at point B so that we'd be able to get the shear and moment. So again, we will be placing a 1 unit load anywhere sa ato ang beam, for it's going to represent the influence of this 1 unit towards the beam and the reaction. So we're gonna see what would be its effect. So it's no longer the same with the shear and moment diagram that we had. So the unit or the load now is already moving. So the influence of the shear and moment now depends on the arrangement of the load. So it's not the same or static anymore. So here, what we're going to do, I have already drawn the beam, and I will try to place the 1 unit load anywhere on the beam. So I'll just place anywhere it on the beam for the 1 unit, and I will be describing that portion of the beams or the 1 unit location to be at X, and we will be solving first the influence line of RA. So meaning to say, we will be placing here RA, and we will be rotating at point C so that RC won't be in the equation. So let's have, actually we're going to formulate the equation. So it's going to be the summation of moment about point C equal to 0, so that we'd be able to get an equation of RA no matter or regardless of its distance. So clockwise positive, counterclockwise negative, and you'll have RA clockwise times the distance from A to C is 16, and the 1 unit to be rotated about point C. So the 1 unit moment arm about point C is this one, the difference between 16 and X, right? So right now we have the influence of -1 counterclockwise times 16 minus X equal to 0. So we will be getting RA now equal to, transpose this to the other side, it will become positive 16 minus not plus, yeah, so it's going to be this one, 16 minus X, and then divided by 16. So simplifying, it's actually just 1 minus X over 16. Okay, so here, this is our equation of RA. For we'd be able to plot now the values of RA whenever the 1 unit load is loaded at each load points, or each load point A, B, C, and D. Okay, so let's copy this beam. So I'll just place the beam here because we will be drawing the influence line later on. So what we're gonna do is, we have at A, X is equal to 0, at B, X is equal to 8, at C, X is equal to 16, and at D, X is equal to 16 plus 5, 21, something like that. Okay, so let's move it a little bit lower. Okay, so when at point A, X is equal to 0, therefore RA is equal to 1 minus 0 over 16. So RA is 1. So RA is 1. So that's a coordinate. So let's say na diri ang 1. So let's just make it visible or obvious. So say this one. Okay. So this is 1 unit here. Let's say that's 1 unit. And then imaginarily, I will be placing in a temporary line that will serve as, or that will give me guide. This one, I'll just draw a line that will be my guide, and I will be pointing C. Okay, so that will be my guide. Anyway, that's not final, so we will be plotting now X at point B. So here at point B, RA is equal to, at point B, X is equal to 8. Therefore, RA is equal to 1 minus 8 over 16. So RA is, that's 0 point, no, this is 1 minus 1/2. So that's 1 minus, what happened? 1 minus 8 over 16. And that's 0.5. So this is the point when X is equal to 8. So we will be plotting that portion. Actually, it's going to form a triangle. That's why I made this temporary line. So this is 0.5. So it's gonna make a triangle most of the time. I mean, all the time. Whenever we have an overhanging beam or a simple beam. Okay, so how about when we are at point C? So at point C, X is equal to 16. So therefore RA, just copy the equation. That's 1 minus 16 over 16. So 16 over 16 is 1. So 1 minus 1 is 0. So as you can see, at point C, it really falls at 0 point here. It falls at 0. And let us proceed to the next one. We are at point D. X is equal to 21. So RA is equal to 1 minus 21 over 16. So RA is, let's compute, 1 minus 21 over 16. That's negative 0.3125. So that's negative. And then it's obvious that it's negative because according sa atong giplot nga temporary nga line, it's on the negative side here. So let's just make a vertical line, and this is negative 0.3125. So therefore, this is the influence line of RA. So that's the influence line of RA. Let us proceed with the influence line of RC. Okay, so for RC, the same. We will still be drawing the figure, the same figure. And then we will be placing the 1 unit load anywhere in the beam. And this is the 1 unit load. Again, this is a distance equal to x, and this time, since we're getting the influence line of RC, so we will now be placing RC here, and we will be rotating about point A so that RA will be eliminated. So let's do now the summation of moment about point A equal to 0, clockwise positive, counterclockwise negative. So RC about point A, it's negative RC times 16. And then the 1 unit load will rotate about point A with a clockwise direction, so that's plus 1 times x equal to 0. So transposing this to the other side, it will become positive, and it will now be x over 16. So this is the equation of RC. Okay, so since na naman the equation sa RC, might as well draw again the beam, the same beam, and then same boundary gihapon. So let's just copy the boundary. So here, that's the boundary, and then let's just copy this for the future. Okay, and let us start. I'll move it a little bit to the left, and we are now at point A. X is 0, so RC is equal to 0 over 16, and that RC is 0. So we're going to plot 0 here, or an obvious color na lang, this one. So this one, and then next is when the point, or when the load is at point B, x is equal to 8. So RC is now 8 over 16, so RC is 0.5. So same thing gihapon, we will be making a temporary line. So just a temporary line, and that one. So I'll just make a temporary line, and that should be a broken line. And then I'm gonna plot 0.5. So by the way, that's 0.5 RC, and so this is 0.5 here. That one, that's 0.5. Let's proceed to the next point. At point C, x is equal to 16. So RC now is 16 over 16, and that RC is 1. So as you observe, whenever ang gipangita nato nga influence line nga reaction, dito mo gawas ang 1 unit. So 1 unit siya. I'm gonna place the 1 unit load here. This one, this is 1 unit. So as you observe also, for RA, since gipangita man nato ang influence line sa RA, then at point A, dito mo gawas ang 1 unit. The same way with point C. Since RC man ang gipangita, at point C, naasa dito ang 1 unit. So that's a reminder lang. Whenever dili ka sure sa imong answer, then mo ni ang mo counter, or mo ni ang mo check whether you got it right, or you got the equation correctly or not, because the equation should give you a value 1 at the respective point kung unsay gipangita nga influence line. Okay, so we're done with point C. Let's proceed with point D. So at point D, x is equal to 21, so RC is 21 over 16. So what is the value? Let's get the calculator. This is 21 over 16. That's 1.3125. And that is the value. And let's plot the 1.3125 from point D up. So this is 1.3125. Therefore, this is the influence line of RC. So actually, kung mag-influence line ta sa any particular point, it's actually going to make a straight slanting line. So it's going to form triangles. So we're done with RA and RC. So proceed with the shear and bending moment at point B. But before that, let us make a table. We have to make a table para dili na to masayop. So for example, whenever naatay value sa RA and RC, so naa siya X. So at X values, so here, dili na lang nako ibutang X value. So if that's the case, when X is equal to 0, and then next is, can I just delete this? And let's just copy this one. Let's copy that. This is for 8, 16, and 21. Okay, so let's make a line. So let's make a line, and let's copy this one for RA, and then for RC, there. Okay, so also X is equal to 8, 16, and 21. So the value of RA when X is at point X equal to 0 is 1. Next is 0.5. Then this is 0. Then this is 0.3125. And then this is for RC, it's 0, then 0.5, and then 1, then 1.3125. Okay, so we're making this table for us not to get lost of the value. So whenever we consider now the shear end moment. Okay, so I don't have a beam, so let's copy this beam. So I'll just erase some. And copy again. Okay, so this time we will be having the influence line of the shear at B. Okay, for the shear at B, we're going to cut the beam. So we're going to cut the beam here, and by cutting, so ito lang ipakita that we're cutting it. So we will be having this one and the other one. Then let's just delete that. Okay, since nag-cut man ta sa kaninga portion, there would be shear and moment. The same way nga napod siya shear and moment diha. So if in case imong shear diha is upward, then here the shear is downward. Then if in case your moment here is a positive bending, then of course it's going to also create a positive bending here. Okay, so I'm not writing any direction yet because I don't want the direction to influence our answer. So I want the answer influence the direction, so it's the opposite. Okay, so I'll just remove this one here, and then this is the portion of the cutting. So I basically need that because this is point B here. Okay, so whenever we place the 1 unit load here, when 1 unit load is at point X, at point A, then we will obtain a value of the reaction RA. So since gikat naman nato ang beam, then basically I will be using this because it's the usual na consideration. Kaya kung mo consider ka dire, then it's going to be the opposite of the sign convention. Remember, we were taught in our mechanics of deformable bodies to consider the left section for us to be able to use the clockwise positive, counterclockwise negative, and upward positive and downward negative for the shear. And that's really important. Okay, so we're basically going to place this 1 unit load at every point A, and then of course since you have RA, then whenever the load is at point 0, and that's point A, so it's going to give you RA equal to 1, right? And then whenever you place the load at B, then it's going to give you RA to be 0.5. And when you transfer the load at another B on the right side, because that's a point of cutting, then you would still be getting the RA. And then again, we will be placing the 1 unit load at point C. So remember that RA at point C is 0, but of course the 1 unit load is no longer in the section that we consider. So next is you place it in the last part. So basically we're going to transfer the 1 unit load from one point to another. And also I hope dili mo maglibog ani nga portion, so let me just make it as a broken line para at least dili mo masayop whenever mo consider mo niya. So I just place a broken line for that para at least may baon ninyo nga it's no longer part sa section. Okay, so what we're going to do now is remember the values of RA. So we will now be solving for shear. So here we will be having summation of forces vertical as equal to shear, or you can have, para di mo maglibog, you can have shear equal to the summation of forces vertical, and that's upward positive, downward negative from your shear and moment equation. Remember this one? Okay, so we have at point A x is equal to 0, so RA is equal to 1. So you have V, or shear, is equal to RA, then upward, and then minus 1. But RA is equal to 1 when the load is at point A. So therefore, why is this shear A? Okay, therefore the shear which is influenced at point B, or shear B, is 0 when the load is 1, when the load 1 unit is at point A. Next, we are at point B, left. So why it's left again? Because we are actually cutting point B, and at point B, so for example this is point B, there are shear yung may experience. So mo to kung ganinang gipakita that shear left at B is shear right of B. So mo na siya. I hope na gets ninyo anong naiingon na ang situation sa B. Okay, so we are still at point B, therefore RA is X is equal to 8, so RA is equal to 0.5, and by that we're gonna transfer this 1 unit load at the left side. So we'll have summation of forces, shear is equal to, again, RA minus 1, but RA is now 0.5, and that's minus 1, so the shear at B is negative 0.5. So that's what we're going to do. We are done with B left. Let us proceed with at point B right side, meaning we will be placing the 1 unit load here at the right side of B, so wala na siya diha, and we will only be focusing this portion of the beam because that's the only section that we consider. Pasabot, the 1 unit load is no longer in the section. So if that's the case, we can have this the shear equal to RA, and since wala na may load diha nga 1 unit, then it's plus 0, or wala na lang kay iswat. And then of course when 1 unit load is at point B, that's X equal to 8, then therefore RA is still the same, 0.5. So shear is RA 0.5. So mo ni mo mga values sa shear of B. Next is we're gonna place at point C, and we have X equal to 16, therefore RA is equal to 0. So RA is 0, and we will be transferring this 1 unit load about, so naman to, we will be transferring the load at point C, so it's no longer part of the section again. Then the shear equation is only RA. So again, we're using this, but the only force nga naa diha is this and that. That's why mo equate na yun siya that shear V is equal to RA, and that RA is equal to 0. This is your shear. Next is at point D, and at point D, X is equal to 21, RA is negative 0.3125. If that would be the case, we will be transferring the 1 unit load except ni C By the way, when I labot si C diha, so diha na si C. So therefore, nag-transfer ang load sa point D, but it's no longer part sa atong section. So the equation would be the same, that V is equal to RA. So therefore, the shear is equal to negative 0.3125. So now we have the points of shear. So ato lang kopyahon ang beam. So let's just copy the beam because we will be drawing the influence line. So let's just remove this and this one. Okay, so we will be plotting influence line of point or shear B. So from 0, ang next niya nga point is negative 0.5 at point B. So that's 0.5 from here, maybe here. So this is negative 0.5 at 1, and then next portion is at the right of B, which is positive 0.5. So positive 0.5 here. This is positive 0.5. So as you observe, we're getting the shear of B, so it's going to be 1 unit if you try to add the value, like 0.5 plus 0.5. So regardless of the sign here, because the effect of shear regardless of the sign is still the same, which is breaking. Okay, next is at point C, the answer here is 0, this one. And then at point D, it's negative 0.3125. So let me just traverse a line. Anyway, it's going to create a triangle. So this one here, this is negative 0.3125, and that is the influence line of shear at B. Okay, let's proceed to the next influence line. The next question is influence line of moment. Okay, the same way, actually we will be using this one, actually this whole thing. Okay, so we're cutting again at point B, but we're solving now the moment at B. So instead of looking at this portion shear, so ato na lang siyang i-remove. Anyway, we're after of the value of this M. Okay, so for M, we will be having this one, using this RA, because we will be considering this section. So kani dili na siya nato i-consider, but we're going to still try to transfer the 1 unit load from each point. And remember how to get the equation done. It's actually M equal to the summation of moments. So it's clockwise positive, counterclockwise negative. Okay, proceed. At point A, x is 0, therefore RA is 1. So for the equation, it's M equal to summation of moment. So RA clockwise times 8, and then this one 1 unit, so that's negative 1 times 8. But RA is 1, so 1 times 8 minus 1 times 8 is just 0. Okay, proceed. We have at point B, So we will be transferring this load at point B. So we will only be having one value of moment. Ang reason, you know already, that whenever naalang tayo going back to shear and moment diagram. So for moment diagram, if you will have two values of moment whenever naakay moment load, like external moment load. Manang duha imong moment value sa imong moment diagram. But since ang atong load is only a vertical load, therefore usa lang ato ang point value sa atong every point A, B, C, and D, unlike sa shear. Okay, so X now is equal to 8, therefore RA is equal to 0.5. So for the equation, M is equal to RA, it's still clockwise, times 8, and then minus 1, then the moment arm is 0 because it's actually at point B. So therefore, M is 0.5 times 8, and the moment here is, moment now is positive 0 point, no, not 0 point, but 4. So that's the value. So we have 0, then 4, then the next point is at point C, and then that's X equal to 16 and RA is equal to 0. I'm always using RA because we're using this section. So if you're gonna use RC, then make sure that you're gonna use this section. So same equation, so M is equal to, but the 1 unit load, by the way, is at point, I'll just transfer. So the 1 unit load is now at point C, but it's no longer part of the section. So the equation will only include RA times 8, but RA is 0, so it's 0 times 8, so M is 0 there. And for point D, so for point D, we have X is equal to 21, then RA is negative 0.3125. So for the 1 unit load, it's basically be transferred here, this one here, but it's no longer part of the section, so the equation would only be RA times 8 gihapon, and then RA is negative, so it's negative 0.3125 times 8. So that's negative 0.3125 times 8. The answer is 2.5. That's 2.5 negative. So these are the values. Okay, we're going to plot now the beam influence line. So let's just copy this. And let's just erase some walay gamit sa pagplot. Okay, so let's start. From point A, it's 0, and then point B, it's 4. Okay, so I'll just place here 4, and then from 0, i-connect lang na nato siya. Next is at point C, it's 0, so it's 0, so it's 0, and then ato na lang i-traverse daan. Anyway, it's still going to give us the answer nga negative 2.5. So if you're not really sure sa imong mga answers, like this one, dili ka sure ana, So what you're going to do is you can basically check that by using the ratio and proportion. So you have 4 over 8. I'm using this and this one, and that is, like for example, wala di ka sure ana, so you just call it as y, and then the distance is 5, so that's 5. So y is equal to 20 over 8, no? And of course it will give you 2.5, so 20 over 8, it's 2.5, as you can see here. So it's 2.5, but make sure that you got it, or you got the correct sign, it's negative or positive. So that's how to check whether you got the answer correctly or not. And also the same way with other figures, like for example, dili ka sure sa imong answer nga negative 0.3125, no? So you just have to check whether you got it right. Like ratio and proportion, like 0.5, you're using this 0.5 over 8, and that's equal to, for example, wala kay sure ana, so gonna have y over this one, since it's actually just forming a triangle. So therefore y is 2.5 over 8. But what is 2.5 over 8? That's 0.3125. But of course, you have to decide kung unsa siya nga side, it's unsa siya nga sign, is it positive ba or negative. So it's really all up to you on how to check that. The same way with this one, no? So since you know already naman that every point or at the reaction, like kani, so at the reaction it will give you 1 unit. So I'm talking about the reactions RA and RC ha. So you know naman already that it's going to give you 1 unit, so you can basically check whether these answers are correct or not. For example, 1 over this, the whole unit, is 16, and that's this one if you don't know. So for example, y, and then that one is 8. So basically it's actually 8 over 16, and that's 0.5. Somehow it's just the same, no? So also for this one, if you're not really that sure, no, kana siya, if dili ka sure, then of course you can use the ratio and proportion. So like 1 over 16 equal to that one, let's say, let's call that as z over the whole length, because we were using a triangle, that's 21. So z is 21 over 16, and that's actually 1.3125. So that's how to check if you got it right. But that actually implies to also reaction A. So that's our first example.